May we invite Professor Helen Mang, Director of the Stanley Ho Big Data Decision Analytics Research Center, to give the first talk. Professor Mang is Professor and Chairman of the Department of System Engineering and Engineering Management, the Chinese University of Hong Kong. She received all her degrees from MIT. She is the former Associate Dean of Research in the CHK Faculty of Engineering. She is also the founding director of the Microsoft CHK Joint Laboratory for Human-Centered Computing and Interface Technologies, which has been recognized as a Ministry of Education field laboratory since 2008. In 2013, she helped establish the CHK Stanley Ho Big Data Decision Analytics Research Center and served as its founding director. Professor Mang's local and international professional services include convener of the Working Party for the 2015 Manpower Survey of the Information Technology sector in Hong Kong, and convener of the Engineering Assessment Panel of the Hong Kong SAR Government Research Grants Council's competitive funding scheme for the self-financing degree sector. She is an appointed member of the Hong Kong Government Steering Committee on e-health record sharing, the Hong Kong Productivity Council, and the former member of the Government's Digital 21 Strategy Advisory Committee and Research Grants Council. She served as the editor-in-chief of the IEEE Transactions on Audio, Speech, and Language Processing and was elected into IEEE Board of Governors in 2014. Professor Mang received the 2009 Ministry of Education Higher Education Outstanding Scientific Research Output Award in Technological Advancements and CHK's Faculty of Engineering Exemplary Teaching Award, Young Researcher Award, as well as Service Award in previous years. She's a Fellow of the Hong Kong Computer Society, Hong Kong Institution of Engineers, and was elected IEEE Fellow for her contributions in spoken language and multimodal system. The title of her talk is Big Data Decision Analytics at CHK. Professor Mang, please.
President Song, distinguished professors from MIT, dear colleagues, students, ladies and gentlemen, good morning. It gives me great pleasure to give you a presentation of our new center. It's a little under 2 years old, Stanley Ho Big Data Decision Analytics. So big data is all the hype. You hear about it every day. The question is, what is big data? In fact, big data is characterized by several V's. They are shown here. So, first of all, big data has high volume, data at scale. We have massive amounts of data, and we need to handle large-scale terabytes to petabytes of data, depending on the domain of application. Big data is data with velocity. It comes at accelerating speeds in terms of its creation, processing, and its need to be analyzed. And sometimes we have to analyze streaming data to enable instantaneous decisions. Big data also comes in many forms. There's structured data, semi-structured data, unstructured data, text, images, audio, video, multimedia, and many different multiple modalities. Also, the V for veracity, data uncertainty. Big data veracity refers to the level of reliability that is associated with certain types of data. And we need to manage the reliability and predictability of inherently imprecise data types. And finally, perhaps most importantly, we need to derive value, V for value, from big data. Optimize decisions. We need to extract intelligence from massive data and improve our decision-making and performance to gain competitive advantage. So this infographic actually gives you an idea of big data coming every minute of the day. So you can see, for example, we have 72 hours of new video going on YouTube. We have WhatsApp is very popular in Hong Kong. We have over 300,000 photos that's shared. Amazon makes 83,000 online sales and so on. So it comes in all the V's. Now, for CUHK, in fact, it is the vision of our leadership to embark on data-intensive research. So with strong support from the Dr. Stanley Ho Medical Development Foundation, Mr. Patrick Huynh and his colleagues, we're able to establish the Stanley Ho Big Data Decision Analytics Research Center a little under 2 years ago. And basically, this center is coordinated by the Faculty of Engineering, so we take a focus on information processing, covering the entire food chain from data capture to processing, modeling, analysis, understanding, manipulating, and visualizing data. And we research in algorithms, computation, and analytics. In terms of the domain, we actually cover 6 major domains: health, environment, learning, logistics, social, and finance. And in the next few slides, I will give you an example of several of the domains covering our work. But actually, we have a lot more projects, so you will get a flavor of what we're doing in the center. Starting with health. So this is work done by my colleague, Professor Calvin Choi, on prescriptions based on patient records. In fact, he had a study where he was comparing 2 hypertensive treatments that are commonly used in the hospital authority system in Hong Kong, perindopril and lisinopril. The data source comes from Hospital Authority, which has a comprehensive computerized patient recording system since 2000 and has some 7 million patient records with clinical and demographic parameters and drug prescription details. In his study, he extracted patients that are prescribed with these 2 treatments in all the public hospital records from 2001 to 2005 and followed through these records till 2010. And it is found that long-term use of lisinopril has significantly higher cardiovascular mortality than perindopril. So big data actually informs us in terms of side effects or risk efficacy of drugs. My second example relates to the domain of environment. In fact, we are concerned with air pollution and health. In the WHO report in 2014, it was stated that the single greatest environmental health risk on Earth was air pollution, because 1 in 8 of the total global deaths in 2012 was due to air pollution, amounting to 7 million people dying due to exposure to the pollutants, of which more than half of the deaths were caused by indoor pollutants, especially indoor cooking stove fuels like wood and coal. So we actually have a group, a very interdisciplinary group, looking into air pollutants. We want to understand the spatial and temporal patterns of air pollutants in Hong Kong through satellite images, visibility levels obtained through pictures and photos. We also look at the ground stations for air quality monitoring, and also we use portable sensors to get the air pollution levels in between ground stations. So we have images and direct measurements, we have fixed equipment and mobile equipment. And the concern is that we want to know and understand our exposure to the pollutants, and in fact, our population becomes susceptible to various diseases that are attributed to these exposures. So we want to understand the environmental exposure matrix on different pollutants at the personal level. This is our grand goal. And in fact, we are mindful of the Hong Kong environment, where we have a lot of traffic at the street level. We also need to look at the high rises and the vertical distribution of air pollutants. So we actually have a quadcopter that flies up and down the engineering building. At each level, it will station itself, and a portable sensor is mounted on this quadcopter. We also measure outdoor and indoor levels, and so hopefully we don't have to wear these masks indoors. But anyway, so this is a very labor-intensive process. But what we want to do is we want to collect all this data, indoor and outdoor data, vertical spatial distributions, and we want to combine with perhaps meteorological data and understand their effects in relation to other environmental conditions and also various indicators of public health. So this is actually a very interdisciplinary group that is undertaking this project from engineering, from geography and resource management, and also from public health. And in fact, our Big Data Center is collaborating with another institute in CUHK, the Institute of Future Cities, which is directed by Professor Leung Yi. The third domain that I'd like to provide you with an example is in the domain of logistics. In fact, logistics is one of the pillar industries of Hong Kong. And we also cover various transportation logistics, commercial business-related logistics processes in our center. But in particular, there's this new area of humanitarian logistics that is of interest to our group. Humanitarian logistics investigates systems and methods in logistics and supply chain operations for disaster relief. So actually here you see the photos of Kasanuma in Japan 1 day after the tsunami, and the bottom one is 2 years after the tsunami. In fact, when people think about disaster relief, most of the time they think of emergency response, recovery in the short term, post-disaster, and redevelopment in the long term, also post-disaster. However, our colleagues advocate the importance of readiness. So we have 4 R's here, readiness. And readiness refers to being aware of the precautions that are needed and being able to be prepared. So in fact, more preparedness will lead to better response. So there's a recent paper published by my colleagues, Professor Jenny Leung and Professor Yong Hong Kuo, on disaster preparedness planning. In fact, they have developed a tri-level mathematical programming model where they look at the pre-disaster case and they plan evacuation center locations and inventory positioning of emergency supplies. They also simulate various scenarios during the disaster, analyze them, prepare for the worst case in each scenario, and the worst case being that perhaps even the evacuation centers that have been planned may be damaged. And they also devise post-disaster measures. So given a damaged scenario, their model determines the distribution network of the delivery of emergency supplies, the quantities of delivery to minimize recovery costs. And moving forward, they want to use big data. They want to enhance their model with multimodal data from sensing and monitoring different conditions, use of historical data for simulation, and also analysis of social media data. And the fourth domain is on learning. In fact, being a student of Professor Victor Zhu, my work largely centers upon speech and language processing. And one of my projects is on online pronunciation training. So language learning is fun. And if you want to speak a language well, you need to train a lot, practice your pronunciation a lot. And in our work, our target audience is for Chinese learners of English. And the motivation was actually, at the time, our vice president asked me, his wish is to improve the general English proficiency of CUHK students. So he says, well, Helen, you have a lot of tools in your lab. Can you put something together? Now, it turns out to be a very interesting research problem. So we actually conducted R&D in mispronunciation detection and diagnosis. And the motivation, of course, the grander motivation is that there are over 2 billion English learners worldwide. And the proportion in Asia alone exceeds the number of native speakers. So we need pronunciation training platforms that are online. And the new technologies can provide new learning platforms that are personalized, self-directed, private, round-the-clock, and providing perceptual and productive learning, and also offering immediate diagnostic feedback. So this is a very interesting area where we see the confluence of linguistics, speech science, pedagogy, and big data research. Because in fact, the approach that we take, which is using deep neural networks, for deep neural networks, you need to train it with a lot of speech data. The more data, the better. So I will show you a very short demo. Guess it doesn't come out. It's okay. I'll show you the demo later. Let me continue. So that was a very brief introduction of our work in big data in the Big Data Research Center. And that leads me to the background of today's workshop. In fact, we are all aware that MIT is very well recognized worldwide in its longstanding efforts in transforming education. It has many pioneering efforts in advancing knowledge to allow students to learn more and learn better. And MIT continues to reinvent the classroom and increase accessibility to education. In fact, CSAIL, the Computer Science and Artificial Intelligence Lab, where all of our 4 distinguished professors from MIT came from, they have a dedicated effort in understanding learning through big data analytics. I can also give you 2 examples of efforts in MIT to transform education, starting with the MIT OpenCourseWare, which was launched in 1999, where MIT was using the internet to openly share education resources. And by 2014, they have over 2,000 courses published, 1 billion page views, and 170 million visits. More recently, there is the launch of edX, which is a MOOC, massive online open course online learning platform. And edX is a nonprofit initiative founded by MIT and Harvard in 2012. And it hosts hundreds of courses with millions of student enrollments. So you may look at this very special logo, and this is looks like a very interesting logo. And in fact, the real building looks like this, right? So with the kind coordination of Professor Victor Zhu, our president actually led a delegation with our provost and Mr. Patrick Kuhn to visit CSAIL in Boston and also edX last June. And we also met with MIT President Professor Raphael Reif, and also MIT's Vice President, Professor Claude Canizares, and also MIT Chancellor of Academic Advancement, Professor Eric Grimson. So there was a lot of discussion on e-learning and big data, and we thank the MIT professors for sharing with us very generously their rich experiences and insights. Now, that leads us to today's workshop, because the visit led us to realize that, in fact, it is very important and timely for CUHK to consider the in-residence teaching vis-a-vis online teaching. In fact, the emergence of e-learning technologies is enabling the education sector to translate in-residence teaching, for which we have a lot of experience, towards online teaching, which is generally a novel, new modality of teaching. But online teaching is very attractive because it offers accessibility to a huge population of students on a very interactive and highly social environment. So moving towards the democratization of education. And such an environment also allows us to capture very valuable big data traces of learning activities that allows us to understand learning processes and learning outcomes. And this kind of learning analytics can inform pedagogical actions, which can improve education both online and in the classroom. So how to establish this feedback loop to achieve symbiosis between classroom learning and e-learning is a very exciting direction for us to pursue for the betterment of education. And this direction is of great interest, not only to the big data researchers, which for now in CUHK is mostly engineers and scientists, but also to our experts in education, social science, and other disciplines. So it is a very interdisciplinary endeavor. So actually with this, I hope I can set the stage for a fantastic lineup of invited talks that are coming up in this workshop. So I guess for now, I will briefly take a break and show you the demo, which somehow I had some technical difficulties. So let me try again. Okay, here. So this is my pronunciation training system, and the student can freely input any text into the system and look at the International Phonetic Alphabet for every word that should be pronounced, that they wish to practice, and they can
Use
play.
ships take cars across the river.
So it will generate a visualization on the fly. This is the articulation animation based on text to audio-visual speech synthesis.
Please
And it is generated in exaggerated modes so to enable better visualization for learning. And so that's perceptual training. But we also want to support productive training where the student can try out and record himself.
These ships take cars across the river.
And with mispronunciation detection technologies, we are able to detect words that the system didn't like so well and show them in red, and the student can click on the model pronunciation
River.
and compare with his own pronunciation.
River.
And also look how this articulation should be done. Okay, so currently it's at this stage, and we actually received a teaching development grant. So this system is actually accessible from all the language labs across the campus, and we hope that it will contribute a little bit towards online pronunciation training. So that concludes my talk. Thank you very much.
Thank you, Professor Mann. The next